It's a great pleasure to be with you, and I have to thank Mary very much for making this invitation possible. I'm going to talk to you about food composition databases and where we see them going perhaps in the future. I've got a number of conflicts of interest because I've worked with the food industry for many years to try and promote plant food production. So these are my conflicts of interest. I think that the important thing is the question. Food composition databases evolve as nutritional sciences evolve, so they evolve in a mutually supportive relationship. Nutritional science is evolving in an attempt to meet global needs. So how will food composition databases evolve? Will they evolve to meet global needs? And I think that's where the interest lies. Food composition databases have evolved already. In 1818, Percy and Bucquelin, calories for prisons was the main objective. Later in the century, Atwater and Woods, and then the beginning of the 20th century, Atwater fame for the Atwater factors, added crude fiber. 1929, McAnson Lawrence was a distinguished diabetologist. Their big interest was on carbohydrate. How could you have carbohydrate diets for diabetes? McAnson Woodison carried on that tradition with food tables, and really a big change came when in 1949 FAO had food composition tables for international use, and I think that's when there was a big international interest growing in food composition tables and what they would do on the international stage. More recently, I think we've tried to make macronutrient measurements more relevant to physiology and pathology. So, for example, protein efficiency ratios based on young rat growth, not just a chemical composition of protein. PD-Cas, protein digestibility corrected amino acid score, digestibility, again, we've got a physiological marker. The driver was growth in the young, so there's still a debate as to what is high protein and what is low protein. Fat, in the beginning, fat was calories. Now CVD is the big interest. First total fat, saturated fat, monounsaturated fat, polyunsaturated fatty acids. Now all the above, and trans fatty acid. So again, the drivers, as we said, Ansel Keys, 7 country studies, saturated fat, increased heart disease. Walt Willett and others, health professionals, nurses, cohorts, increased trans fat, increased CVD. We don't have randomized controlled trials. This is the interest. Saturated fatty acid, CVD mortality, still debated. It depends really on what your comparison is. But I think we've gone a long way from just looking at just fat. Carbohydrate, let's focus on fiber. Interestingly, how this has changed. In the original time, it was in 1896, Atwater classed it as refuse. That was fiber. Then later on, included it as crude fiber. And these were negative associations. These weren't positive associations with diet. Positive associations with diet came around the time that John Harvey Kellogg put out All Bran. All Bran became a popular high fiber breakfast cereal, had a positive association. Again, as we said, 1929, McAnson, Lawrence, they were really more interested in carbohydrate for diabetes. Fiber was a sort of neutral thing that you shouldn't include. Then it became positive in 78 and onwards, as we go into the more modern era, largely due to Dennis Burkitt and Hugh Trowell, who returned from Africa and said that fiber was good for us and stimulated the British Medical Research Council to do a lot of work on fiber and showed that it was indeed an interesting food which had good correlations with health. So fiber has become something that we're interested in. But it's not a chemical definition because it's a complex set of substances. And in fact, it was early on, it was said we can't define it, we can't measure it properly, and therefore we can't regulate it. So it was always a bit of an enigma because it was really a physiological marker. So again, we entered the physiological era. More recently, there are a number of carbohydrate issues, the resistant starch, are there health benefits? Is resistant starch good for you? Is it a fiber? It may measure as a fiber, but is it a fiber? Sugars, fructose, health problems with soft drinks, certainly. Is it the calories or is it the actual sugar? Soluble versus insoluble fibers. Is this a definition that's relevant? Is the fiber source relevant? Fruit versus vegetable versus cereal, which is best? Which sort of fiber is best? Should this be some sort of annotation for this? Fiber viscosity, oats versus wheat. Oats lower cholesterol, they're viscous fibers, but both oat and wheat reduce CVD. Wheat doesn't lower serum cholesterol. Is the glycemic index relevant? So that's one of those are the sort of topics that I'd like us to think about as we go forward. Let's look at viscosity, fiber viscosity and blood glucose. Early on, we were able to show that the more viscous the fiber, the guar, the greater the flattening of a glucose tolerance if you mixed it with the glucose load. You saw the same sort of thing with tragicans, but less viscous, less of an effect, and a more minimal effect with pectin. You also saw effects with methyl cellulose. Some effects are not significant with bran and with the man-made fiber cholestyramine used as a cholesterol-lowering agent. These insoluble materials have much less of an effect than the more viscous materials, the guar and the tragacanth. So again, there is a viscosity story here, presumably due to a reduction in rates of absorption from a viscous small intestinal content. What about viscosity and cholesterol? Well, the more viscous the fiber, the more it lowers serum cholesterol, as you can see here, change in serum cholesterol. So again, guar, pectin, tragacanth over here would all be lowering serum cholesterol, but very little effect on fecal bulk. The less soluble components, especially wheat bran, have the big effect on fecal weight. So I think, again, we've got differences within the fiber story, differences in effects. But nevertheless, viscous fiber has entered guidelines for clinical treatment. The National Cholesterol Education Program, ATP3, in the US, featured viscous fiber as being important. Canadian Cardiovascular Society, Heart UK, European Atherosclerosis Society guidelines for statin-associated muscle symptoms. They all mention the importance of viscous fiber or the use of viscous fiber in reducing serum cholesterol. So we do know that some types of fiber do have cholesterol effects, and fiber in general, even cereal fiber, seems to have important effects in terms of overall cardiovascular risk reduction. So much about the types of fibers still to be resolved. So that's part of the thing that do we have this in the database? The relation of fiber to overall viscosity of food digestion is unclear, including the effect of the same fiber purified or in a food matrix. So if it's a food matrix, does it have the same effect as if it's a purified fiber added to a food? However, supplementary purified fibers are effective in reducing postprandial glucose and cholesterol lowering. So is it worth having a column for viscous fiber in food tables? What about the glycemic index? Is that worth a column? the glycemic index really gives you a physiological indication of the rate of digestion of the carbohydrate food, and that's what determines the glycemic response. A more recent physiological addition to certain food tables. So we do have some international tables, for example, by Jenny Brown Miller in Australia, which are very comprehensive on dietary fiber values for foods internationally, following up on the 1949 FAO concept of the internationality of food tables. So postprandial blood glucose is measured as the area of 50 grams of carbohydrate from food expressed as the 50 gram percent of glucose postprandial rise. So basically it's just the rise that you get after glucose and the food's expressed as a percentage of that, the food rise. Quite simple. What's the relation to in vitro amylolytic activities? It really just a digestion marker. If you look at in vitro digestion of starchy foods, different starchy foods with salivary amylase, this is what you see. 1 hour, this is the sort of association between the carbohydrate concentration in the dialysate and the glycemic index. So really quite a nice relationship, and obviously increased at 3 hours digestion. So there is an association with digestion and the glycemic index, which is quite strong, as you'd expect. If you look at the early food table that we put together, looking at different foods, one can see that looking at grains and cereal products, interestingly, if you look at white and whole wheat bread, brown bread, fiber-rich bread, not much difference in glycemic response, up in the sort of 70% of glucose sort of range. If you look, on the other hand, at pasta, spaghetti, either wholemeal or white, round about sort of 45% of the glucose response. So really, these are not different in terms of the macronutrients that you'd have recorded, or the nutrients you'd have recorded in a food table, but they give very different glycemic responses. And this is even more clear when one looks at legumes as a class. If you look at legumes as a class, they're all relatively low in terms of their glycemic response. So if sort of 50 to 60 is the average, then these are certainly below average in terms of glycemic response. And so, as you'd expect, this is the glucose response to pasta. Really, as we said, about sort of half that you would get for white or whole wheat breads. And the whole wheat breads or white breads don't make much difference when you look at their 50-gram portions fed to healthy volunteers and look at the postprandial blood glucose response. What about beans? These are certainly old foods. Here's the Bean Eater Renaissance painting, 1585. So we've been eating beans for long before that too. What sort of beans are we talking about? Many sorts of beans: peas, beans, lentils, legumes in general. What's their glycemic response? Well, their glycemic response is uniformly, as we showed, very low and different from the other starchy foods, grains, breads, breakfast cereals, cookies, tuberous vegetables. They have a range amongst themselves, but are already very different from those of beans. So what we can see is that certain foods and certain classes of foods have almost a therapeutic effect, a drug-like effect in terms of reducing the amount of starch or the amount of carbohydrate they contain. So can we use this therapeutically? Certainly we have, and this is a 6-month study of a high cereal fiber diet in 104 people, a low glycemic index diet in 106, and you can see that the low glycemic index diet over the 6-month period reduces the hemoglobin A1C as our marker of blood glucose control, long-term blood glucose control. The differences aren't large, but they're consistent and significant, and they certainly take one from being moderately controlled into being relatively well controlled in terms of diabetes. So these are type 2 diabetic patients already treated, I have to say, already treated on anti-diabetic medication, so already well treated. If one looks at the glycemic index and diabetes incidence, it seems to have a relevance there. And this is a study by Jeff Livesey, a meta-analysis showing that if you look at the various studies that have been done, at the bottom line, the diamond is to the right side of the unity line, indicating that higher glycemic index diets in general increase the risk of type 2 diabetes. So I think that's important. The better the FFQ used, these are FFQs with correlations with nutrients of less than 0.55. These are the less good, and these are the good studies, if you like, with good food frequency questionnaires, showing, if you like, a better effect. But nevertheless, overall, still a significant effect, a significant reduction. What about heart disease? Interestingly, if something affects positively diabetes, then one does expect some, or would like to see some positive effect for heart disease. And this is a study by Simon Liu, looking at the nurses' health professional study, the nurses' health study, 65,000 nurses, and this is glycemic load, and this is the relative risk of coronary heart disease. And what one can see is as one increases the glycemic load, which is the glycemic index times the total carbohydrate, one can see a gradual increase as one steps up from tertile 1 to tertile 3. On the other hand, they looked at BMI at the same time, and if your BMI is low, less than 23, all of you in the audience will be in this range, I'm sure, then you see very little effect. So basically, as we get older and fatter, then the glycemic index becomes probably more important, and certainly more important in terms of cardiovascular disease. If you look at page 53 in the supplement of the WHO Commission meta-analysis on glycemic index by Reynolds and Jim Mann and John Cummings, published in The Lancet in 2019, you also find some very interesting things on glycemic index. What they were able to show is that CVD mortality was significantly increased with high glycemic index diets. Not many cohorts, just 2, 3 cohorts for stroke mortality. And here was a tremendous 58% increase in risk with high glycemic index diets, well clearing the unity line. So very significant for cardiovascular disease, as one might expect. Stroke incidence also increased as one increases glycemic index. Type 2 diabetes, breast cancer, esophageal cancer. So I think we have a number of diseases that we don't want to get ourselves and don't want our patients to get that seem to be related to higher glycemic index diets. I have to say that you have to read page 53 of the supplement to get that, because the conclusion in the actual Lancet paper that Reynolds and friends came to was that the glycemic index didn't work. I think if you look at their data, it does work. Unfortunately, most of us only read the bottom line of the abstract, and certainly to read the paper is sometimes a strain, and you don't go to page 53 of a 200-page supplement to get your information. But anyway, if you go there, that's what you'll find. You'll find that things are not going so badly for the glycemic index as they said in their actual report. So, stimulated, in fact, in many ways by Andrew Reynolds and Jim and John Cummings, we were able to look at the PURE study. We set out to look at the PURE study. very kindly invited to by our friends at Master, who have the Prospective Urban Rural Epidemiology cohort, which is, I think, by far the largest international cohort that we have ongoing, with 135 participants, 35 to 70 years of age, 20 high to low income countries, 5 continents, 7.7 years duration. And interestingly, because countries in Africa, Latin America, and the Middle East, which have not been surveyed, were included in this survey. What we saw in this cohort, looking at glycemic index and cardiovascular disease, was, if you look at major cardiovascular events, CVD death and stroke, increased glycemic index increased the risk for all these. This is in the total cohort. Those who had no CVD risk at baseline, and then a somewhat increase effect, as one might expect, in those who had evidence of CVD at baseline. So I think that was nice that it confirmed what has already been seen on an international basis. And total mortality, this is the dose response for total mortality, and this is the dose response that was seen for major cardiovascular disease. So I think what one's seeing is dose responses which give one more confidence in the data. Overweight, again, was an issue, and if one looks at the composite outcome in those who are normal weight, less than 25 BMI, versus those who are overweight, you see it is in the overweight that you see the greatest effect, as we would expect from the earlier studies of Similu and Willett in the nurses study. So I think that's good. What happens then if one takes the pure cohort data and inserts it in the meta-analysis data of Andrew Reynolds? Then one sees these are the Andrew Reynolds data, and this is the pure data, and a very nice diamond clearing the unity line, 26% increase in risk of cardiovascular mortality with high glycemic index diets, and nicely clearing the unity line. So I think the inclusion of these data further strengthens the Reynolds data, and I think might need a reassessment of the way they wrote their 2019 Larson paper. So do we need to assess dietary patterns? Pattern that's well known to everyone. So what happens if one looks, for example, at the association of Mediterranean diet with diabetes incidence? Well, these are the sort of responses that one sees, and in fact one sees a protective effect. I'm sorry, the data aren't clear here, but this is this paper by the authors in Advancing Nutrition has not yet been published. This is just was accessed May the 2nd. But again, one sees a protective effect of a Mediterranean diet on diabetes incidence. So does that mean that we need to know something? Would it be useful physiologically in food tables to know what contribution the food might make to a Mediterranean diet? Probably finally, the planet's the sickest person in the room. We're all worried about the effects of global warming, the effects of planetary destruction, and the IPCC has warned us that we don't have too many years to go if we carry on at the same rate. Interestingly, Eat Lancet came out advocating a link between diet and greenhouse gas emissions and climate change. And the New England Journal of Medicine recently came out suggesting that climate change should be part of medical education, which it's not right now. We don't have courses on climate change. Just to look quickly at carbon footprint of protein-rich foods, if one takes the beans, the pulses, soy, other foods, the legumes as a source of protein, low glycemic index foods, and compares them with beef, then you've obviously got a big difference here in terms of CO2 equivalent production. So I think this is interesting. So should these figures, should greenhouse gas emissions be in a part of food tables? So basically our concerns, our worries are not only about deficiencies, which is the original reason that we looked at nutrient databases and we constructed food tables. We're looking at chronic diseases now. We're also looking at planetary health. So should we have greenhouse gas emissions, water use, land use, pesticide use, species loss, columns in food tables? In other words, should we classify foods according to their contribution to these sorts of outcomes in say, a 2,000 kilocalorie diet? The younger generation are worried about humane agriculture. Should we have a humanity index? So which foods are humane foods to eat and which foods are less humane? So again, one can see a broad range of different things that one could use the classic food table to help us with. It's worth mentioning too that recent evolution of dietary guidelines internationally has gone more plant-based and more planet-friendly. It started off with Sweden in 2009, first to incorporate environmental concerns into guidelines. Holland in 2015, no more than 2 servings of meat per week, not only for health, but also for the planet. Vegetarian diet in the USA was one of their 3 healthy diets. China reduced meat consumption by 50%. UK eat beans, pulses, less red and processed meat. Belgium make foods derived from plants the basis of every meal. Limit your intake of animal products. And in Canada, first principle, regular intake of vegetables, fruits, whole grains, protein-rich foods, especially plant-based sources of protein. So I think we're going into a more plant-based advice for human consumption that will include carbohydrate and will include fiber and will include possibly interesting glycemic index of the sorts of carbohydrate foods we're eating. So I think those are my wrap-up, as it were, for the relevancy of what I've been talking to you about, just in case it doesn't seem relevant. So what do we see? Well, obviously, we've traditionally had nutrients, and that's what our food tables have contained. Physiological effects, in other words, are they physiologically effective? Is there some facet about them that gives them a physiological effect? So, if you like, viscous versus non-viscous fibers. Is that worth putting in? Should we actually have the physiological effect, cholesterol lowering? Is that worth putting in if you know that for a food? How do they contribute to dietary patterns, certainly the good dietary patterns that they want? What are the pathological implications? Can we say that these are potentially contributors to so much contribution to heart disease or not? Columns for environmental impacts, those two might be useful, and possibly a column for humanity. So those are just some ideas. So in conclusion, food composition tables have evolved rapidly over the last 200 years. Interestingly, the period of population explosion, Malthus, remember, was 1798, and he predicted what was coming long before it came. We're moving into the area of physical and physiological characteristics of foods. Other factors such as plant phenolics, steroids, saponins, phytates, chelating agents, antioxidant activity may be given greater prominence. They may also deserve columns if they don't already have them, and if they do, more complete data. So an enormous amount of potential work could go into the classic food table. And more comprehensive food composition tables will greatly enhance research on diet and health, and in turn will further refine the tables. And we'll be able to move the columns either closer or further from the front, or I would suggest probably have several classes of the table dealing with specific issues. But it will allow those who are looking at dietary data to have a very full range of ideas of what the diets of the folk that they're eating will be having, both in terms of on themselves and on their planet. So I think that would be what I would hope for the future. When do I see this happening? Probably by the turn of the century. So I will leave the rest of you to look at that. I'm afraid I'll be someone else's nutrients by then. Thank you.